Hey everybody, this is Mr. Piercy, and what we're going to be looking at in this lesson is how we use the rules for special right triangles, meaning a 45, 45, 90 right triangle and a 30, 60, 90 right triangle, where 45, 45, 90, and 30, 60, 90 refer to the angles inside of the triangle. So looking at the first one here, we have a 45, 45, 90 special right triangle, where they're just simply telling you that the hypotenuse is whatever the length of the leg is multiplied by the square root of 2. So we have this rule here that we refer to, and generally the way I kind of shorthand it is I'll say capital H for the hypotenuse is equal to the leg times the square root of 2. And that's how we will kind of set up and solve uh, equations using 45, 45, 90 special right triangles. So let's take a look at a couple of examples. Now again, for the most part, we can kind of follow along with the information that we have here. As far as, we can just kind of read through the solution and see what we wind up with. But let's take a look at the triangles themselves first and, see how they go. So let's take a look at A on the left side of the screen here. Well, the rule for a 45, 45, 90 triangle says we're going to take the hypotenuse and we're going to make it equal to whatever the leg is, multiplied by the square root of 2. That's the rule that we use. It's just kind of like using the formula for area of a triangle or something like that. We're going to just use this rule and then substitute things that we're looking for. So in this case, I don't know the length of the hypotenuse, so I can call that x. So I can say the hypotenuse is equal to the length of the leg, which is 6, multiplied by the square root of 2. And really, that's about as far as we would take it for this example, because mostly what we're going to be doing in high school is we're going to be leaving our answers as simplified radical numbers, as exact answers. So here, this is where I would stop as an exact answer. And if I wanted to know what it was as an approximate answer, I would actually type it in on the calculator and say 6 times the square root of 2, and that would give me approximately 8.485 for the approximate value of the hypotenuse. So let's take a look at figure B and see what they do. And we'll go through here and see, plug in the information in the blanks here. But these are the kinds of things that you're going to see on your assignment. You're going to just, here's a triangle, how do you work it out? Here's a triangle, how do you work it out? You're not going to see all this fill in the blank stuff with the solutions that our notes are providing you. But we'll go back through and fill them in for sure before we move on. So again, I'm going to say, well, let's look at B here. The rule says take the hypotenuse and make it equal to the leg multiplied to the square root of 2. So in this case, the hypotenuse is again what we're looking for, so I can call that x. So I'll say x is equal to, now the length of the leg in this case has a radical number. So I'm going to substitute for radical 2 in for the length of the leg, and I'm still going to multiply it to the square root of 2 that's given to me by my rule. Well, multiplying through here, radical numbers get multiplied together kind of like the way variables in algebra get multiplied together. So if I said a times a, that would be a squared. Well, it's kind of the same thing here. We're going to multiply the radical stuff together. So the square root of 2 times the square root of 2 gives me the square root of 4. And the square root of 4 simplifies to be a 2. So the hypotenuse in this case works out to be 8 units long. So let's see how we're going to fill in the blanks here. You might have already been able to fill in the blanks as we were going on. So the triangle sum theorem, the measure of the third angle has to be 45 degrees. So I know that this is a special right triangle. I also know it's isosceles because I have two angles that are the same. The only time I have two angles that are congruent in a triangle is if the triangle is isosceles. So here we're saying that the hypotenuse has to be square root of 2 units times longer than the leg, and substituting the values, just like what we saw a second ago, we get 6 radical 2. Here, the base angles theorem, this is what I was referring to, says that because the two angles are the same, that this is also going to be a 45, 45, 90 triangle. And we set up the rules saying the hypotenuse is equal to the leg times the square root of 2. Substitute your values, and in this case, the hypotenuse works out to be 8, which is what the work showed us in blue on the right side at the top of the screen. Now, if you have any questions about anything that I'm doing as far as how I'm showing the work or why we're substituting numbers in the way that we're, substituting them, please let me know. Now here we have two examples. One of the examples is given to you in your notes. The one on the left is just an additional example that I gave you because I think you need to see another example here. The last two examples, both of them gave us the length of a leg and asked us to find the value of the hypotenuse. Well, here they're giving us the value of the hypotenuse and asking us to find what's the length of the leg. Now we could use the Pythagorean theorem here and find out what the lengths of the legs were going to be, but the shortcuts with the 45, 45, 90 special right triangle will actually be simpler. And we do need to see some of the types of math associated with this stuff with our radical numbers that the Pythagorean theorem doesn't necessarily give us. Now here, because I have two sides that are the same and it's a right triangle, that allows us to conclude that the only way that these angles can be whatever they are is because they have to both be 45 degrees. Because the side opposite of those angles are the same, the measurement of the angles has to be the same, and the only way they can do that and the third angle be a right angle is if both of the given angle or both of the unknown angles have to be 45 degrees. So we can conclude that the triangle that we're working with is a 45, 45, 90 special right triangle, which allows us to use the rule. It says the hypotenuse is equal to the leg times the square root of 2. Now we just substitute the values that we know. In this case, the hypotenuse is the square root of 2. So I just say the square root of 2, or 9 times the square root of 2 for the hypotenuse. The leg is x, and the rule says we multiply the leg by the square root of 2. Now we're trying to find the value of x. So at this point, we're going to divide both sides by the square root of 2. Now anything divided by itself always simplifies to be a 1. So here, square root of 2 over the square root of 2 simplifies to be 1. Square root of 2 over the square root of 2 on the left side of the equal sign also simplifies to be 1. So all we're left with is 9 for the value of the legs. Now, and that's a really easy problem to work out, or to work out, because it's reasonable to say, oh, if the hypotenuse is 9 radical 2, then the leg has to be 9, because you can say the leg has to be equal to the hypotenuse times the square root of 2. Or I said that backwards. The hypotenuse has to be the leg times the square root of 2. So we can just kind of knock off the square root of 2 on the hypotenuse, and that gives us the leg. But a lot of times you're going to see examples like what we see here on the left, where the hypotenuse is not a radical number. It's a whole number. It's a 10. So how do we do this one? Well, we're going to set it up the same way. We're still going to say the hypotenuse is equal to the leg times the square root of 2, and then substitute our values. So here I have the entire problem worked out, so you can kind of see what we're doing here. Substituting 10 for the hypotenuse and x for the length of the leg, we get 10 is equal to x times the square root of 2. And we're going to divide both sides by the square root of 2, just like what we did in example 2. So on the right side, square root of 2 over square root of 2 simplifies to be 1, so 1 times x is just x. Now on the left side of the equal sign, we have 10 divided by the square root of 2. And this is where a lot of us are going to be tempted to stop. Well, let me give you this little bit of information here. The square root of 2 is classified as what we refer to in math as an irrational number. An irrational number is a number that has a non-terminating, non-repeating decimal number. If you happen to have a calculator handy, if you type in the square root of 2 onto your calculator, you're going to say that the square root of 2 is approximately equal to 1.414213.562, and that's all the numbers that my calculator will display. the numbers never stop. It's a non-repeating, non-terminating decimal number, kind of like pi is. So it's not possible for us to divide with the square root of 2, and essentially that's what this is telling us to do. This is saying 10 divided by the square root of 2. So it's not possible for us to divide with an irrational number. So what we do here, this step is what we refer to as rationalize. Rationalize the fraction. And what we're going to do is we're going to take whatever that radical is in the denominator, and I'm going to multiply it to both the numerator and the denominator at the same time. So in the numerator, 10 times the square root of 2 is 10 times the square root of 2, just like 10 times x would be 10x. In the bottom, square root of 2 times the square root of 2 gives me the square root of 4, which ultimately simplifies to be a 2. Now we have a 10 over a 2, and those simplify to be the number 5, leaving us with 5 radical 2 as the length of the sides for that example. And you're going to see problems like that in your practice problems, on your quizzes, on your tests. So it's very important that you know how to work the math. It's not just knowing the rule for the special right triangle, it's what do I do if I have a radical number in the denominator? How do I take care of that? And that's called rationalizing. So here, take a look at the two questions that we have here. Try working them out. Pause the video, work these questions out, and when you're done, come back and compare your answers with see how mine look. Okay, so hopefully we have you've done what I've asked you to do. You've paused the video, worked out the problems, and see what the value of the missing sides are. So in example 1, we want to know what's the length of the hypotenuse. So we start with the rule. Hypotenuse is equal to the length of the leg times the square root of 2. Substitute your numbers and do the resulting math, and we say that the hypotenuse in this case is going to be 4 units long. For example 2, same thing. Hypotenuse is equal to the length of the leg times the square root of 2. And in this case, when we divide both sides by the square root of 2, in this case, they both simplify to be 1 in this example. So we're left with the length of the leg to just be 12, kind of like what we saw in example 2. But keep in mind, the hypotenuse is not always going to have a radical 2 on it. It might be a whole number. It might not even be a radical number. It might be a radical 5 instead of a radical 2. So you still have to do the math according to what we normally do when we multiply and divide numbers. So here's an example of a word problem where we're kind of associating special rules for a different special right triangle. Here the triangle that we're working with, the guitar pick, is basically an equilateral triangle. Well, the length of the altitude of an equilateral triangle is also the median, so it's going to bisect the third side of the triangle. That's kind of what this is telling you here. And since each side of the triangle is the same, the segment here at the bottom gets divided equally. So this is 16, this is 16. And the last thing we need to remember about the altitude of an equilateral triangle is not only is a median, but it's an also angle bisector. So here we have our 90-degree angle, here we have our 60-degree angle. So the triangle sum property says that this one here has to be 30. And that's what allows me to conclude that I'm working with a special right triangle, 30, 60, 90 in this case. Now, filling in the blanks here for what we're looking at, we've established that this is a 30, 60, 90 triangle, and the rule, one of the rules, says that the length of the leg is equal to, the long leg is equal to the short leg times the square root of 3. And the way that I will kind of shorthand that is I say LL for long leg is equal to SL for short leg times the square root of 3. So if I wanted to know what the height of this particular triangle would be, here we're going to substitute the values and say the height is equal to the long leg in this case is the height of the triangle that we're looking at. Let me just kind of here, this is the triangle that we're looking at. So this is the long leg. this right here would be the short leg, and obviously that's the hypotenuse. So substituting the numbers, we would say that the height of the triangle would be 16 radical 3 units long as an exact answer, or about 27.713 millimeters as an approximate answer. So here is a 30-60-90 triangle. We want to know what are the lengths of the missing sides. Now here we can kind of just go ahead and fill in the blanks here because they do a pretty good job of setting up the problem and working it out the same way that I would without filling in the blanks. So let's go ahead and find the value of x. Now the reason why we have to find the value of x first is because the hypotenuse and the long leg both depend on what the short leg is. So let me just put the equations here. There's two rules that we have. We have the hypotenuse is equal to the short leg times 2, and we have that the long leg is equal to the short leg times the square root of 3. Well, in this case, the short leg is, if we were in algebra, I would refer to this as my independent variable. Where the long leg in this case and the hypotenuse in this case, they are the dependent variable. So whenever I have a 30-60-90 triangle, if I don't know what the length of the short leg is, I have to find that first because the other missing side, in this case the hypotenuse, depends on whatever the short leg is. So let's go ahead and substitute our stuff here and see what we wind up with. We are given the length of the long leg, so that's why we're starting with this formula first. Because they gave us the long leg, we got to find out what the short leg is. So I'm going to substitute the square root of 3 here. And in this case, substitute your numbers. The long leg is 8. So x is going to be the short leg. So we have 8 is equal to the x squared root of 3. And just like what we saw with the 45, 45, 90 examples, we're going to divide both sides by the square root of 3. Now, just like what we saw in the last example that I gave you, where the hypotenuse was the length of 10, and we had a square root of 2 in the bottom, we can't have the square root of 3 in the bottom of a fraction because it is an irrational number. So we rationalize it again. We take whatever the radical in the bottom of the fraction is, multiply it to both the top and the bottom. In the numerator, 8 times the square root of 3 is just 8 times the square root of 3. And in the bottom, square root of 3 times the square root of 3 gives me the square root of 9, which simplifies to be a 3, which we see in the bottom of the fraction. Now, we have a whole number 8 in the top and a whole number 3 in the bottom. If those could simplify, we would simplify it. But in this case, 8 does not divide by 3 equally, so we just leave 8 radical 3 over 3 as our answer. So now we want to know what the length of the hypotenuse is. So I'm going to say the hypotenuse is equal to whatever the short leg is times 2. So the hypotenuse is the variable y, so I'm going to substitute that in, and I'm going to say 2 times 8 radical 3 over 3. Now remember, when we multiply fractions, multiplying fractions is no problem, top times the top, bottom times the bottom. So 2 is the same thing as really just 2 over 1, so the 2 gets multiplied to the 8 in the numerator of the fraction on the right, giving us a 16 radical 3. And in the bottom, we just have 1 times 3, which just gives us a 3. So our final answer as an exact number would be the 16 radical 3 over 3. And again, same thing, 16 and 3 are both whole numbers. If they could simplify like a normal fraction, we would, but 3 is not a multiple of 16, so we can't simplify the fraction, so we just leave it like that. So now we're going to take a look at an example of a word problem here. We have windshield wipers for a car that's turned off. So you ever stop your car when the windshield wipers are on? They don't just go back down to the original, to where they're positioned when they're not being used. They just stop wherever the car stops at. So here we have the windshield wipers that are stopped where they're kind of forming a 30, 60, 90 triangle. Well, in this case, the hypotenuse is the length of the windshield wiper, which is 24 inches. So The question is asking us how far from the bottom of the windshield are the ends of the wipers. So what it's asking us to find, it's asking us to find that length right there, which is the long leg. So again, I don't know the length of the short leg, and the long leg depends on the short leg, so I do have to find the short leg first, then I can find the length of the long leg and know the answer to the question that we're being posed here. Substitute the values. Hypotenuse is equal to the short leg times the square root of 2. Oops. Sorry. Said that backwards. I confused my 4590 rule here. The hypotenuse is equal to the short leg multiplied by the square multiplied by 2. I keep wanting to say square root. I don't know why. So here we're going to say 24 divided by 2. So in this case, the short leg is going to be 12 inches long. Now we can say that the length of the long leg is equal to the short leg times the square root of 3. So substitute the values here. In this case, D is what they're referring to as the distance from the top of the wiper to the bottom. That's the length of the long leg. Substitute what we have here. The length of the short leg is 12, so we have 12 radical 3. So 12 radical 3 would actually where I would stop as an exact answer. So I would say it's 12 radical 3 inches long. As an approximate answer, it's about 20.785 units. Now remember, in pre-AP math, we always rounded to 3 decimal places because that's what your AP exams and calculus will ask you to do. So we always practice it by rounding to 3 decimal places unless we're told otherwise. So here we have some checkpoint questions for you guys to try practicing these on your own. Go ahead and pause the video and see what you get for your answers here. And when you're done, when you have your answers, go ahead and hit play again and come back and see how your answers look with mine. All right, guys, hopefully we have good answers on your paper, and even if they're not good answers, make corrections however you need to, because this is just practice, and there's nothing wrong with making a mistake in practice. So here we want to know what's the value of the missing side. In problem 3, what's the length of the long leg? So I'm going to start with writing my rule, and I'm going to say the length of the long leg is equal to the short leg times the square root of 3. Substitute my values. So the short leg in this case is 2 radical 3, so I still have to multiply that by the radical 3 that the rule gives me. The radical 3's multiplied together to give me the square root of 9. Square root of 9 simplifies to be a whole number 3, so the missing side in this case is going to be 6 units long. Problem number 4 is kind of like what we saw with the guitar pick question. We have an equilateral triangle. When I divide an equilateral triangle into 2, I do wind up with 2 30, 60, 90 special right triangles. And in this case, again, we're looking for the long leg. The long leg is the height of the triangle. So substituting my numbers here, I'm going to say the length of the, start with my rule, long leg is equals short leg times the square root of 3, and just substitute. In this case, the short leg is 3, so I get 6 radical, I'm sorry, the short leg is 6, not 3, I'm sorry. The short leg is 6, so I wind up with 6 radical 3 as an exact answer, or about 10.392 if I had to round it. And the last question here, example 5, how far the bottom windshield would be if they made a 30-degree angle with the bottom of the windshield instead of a 60-degree angle. So here, essentially we have the same looking one. I just took the image that we had from the example, but instead of it being a 60-degree angle, now we're looking at a 30-degree angle. So we kind of have a triangle that would look a little bit more like that. Well, the length of the windshield wiper is still 24 inches. So, and we're still asked to find the same thing. How far is it above the windshield? Well, in this case, the way the triangle is set up, now we're looking for the length of the short leg. Since the length of the short leg is equal to the hypotenuse, the hypotenuse is equal to the length of the short leg multiplied by 2, that's the rule that I used to set up here and show with some simple division that the missing side of this triangle, pardon me, is going to be 12 inches. So that's it for the notes on 36 and 90 triangles and 45, 45, 90 triangles. Remember, oops, for 45, 90 triangles, we only have one rule that says the hypotenuse is equal to the length of the leg times the square root of 2. For 30, 60, 90 triangles, we have two rules. One that says the hypotenuse is equal to the short leg multiplied by 2, and that the long leg is equal to the short leg multiplied by the square root of 3. And also, don't forget what rationalizing means. I can't spell it today. Go back and look at the examples where we had to rationalize. Remember, you cannot leave a square root number in the bottom of a fraction. You have to rationalize it by multiplying whatever that square root value is to the top and the bottom of the fraction. So any questions that you've seen or any questions that you have about anything that you've seen in this lesson, please guys email me. Let me know what your questions are, and I'll be happy to answer them, work with you, and see how we can get things cleared up. But until next time, ladies and gentlemen, thanks for watching and take care.